Hello everyone, my name is Chris Swaim. I'm the Territory Technical Manager covering the SOLIDWORKS PCB products for the Eastern and Southern US, as well as Eastern Canada. And today we're going to talk about the SOLIDWORKS PCB connector. Let's look at your current methodology for interfacing between your printed circuit board design environment and your mechanical environment. In the creation of a board outline, how many times do you have to go through and make changes, whether you're creating the board within the printed circuit board design environment or the mechanical engineering environment? It's an iterative process going back and forth to make sure that it's done correctly. And how do you accomplish this? Are you using STEP, IDF, IDX? How many times are you sending this data back? And in terms of the communication of engineering intent, are you using Outlook, notes, sticky pads? It's a very cumbersome methodology, and it takes a while to get it correctly. And then what about placing those components? Again, trial and error, manual checking, and sending data back and forth using the aforementioned interface files. And how do you track the changes? Well, quite frankly, there is no easy mechanism for documenting all the changes that occurred. Again, we're relying heavily on the perception of the engineers within the respective disciplines, and things get missed, things go wrong. So let's look at the SOLIDWORKS PCB connector. There's definitely a better way. You can start the design, the board outline definition, either in the mechanical space or the printed circuit board design space, and it can be derived from the exact space within which that board will need to be placed. The board outline can be started in either environment, changes can be made to either environment, but it's always with respect to the exact requirements. We are not doing any data exchange using an interface file or doing any sort of conversion or translation. We're using the exact design data. Those designs are managed through the SOLIDWORKS PCB service, which is an integral part of the connector. And what about ensuring that the components are placed correctly from an electrical perspective? You can use the schematic to ensure that you're using the electrical intent in placing those components. You can send the board with the components over to the mechanical engineering environment to make sure that they meet all requirements, including fitting within an enclosure, mating with connectors, etc. You can always perform interference checking using the automated routines that is an integral part of the SOLIDWORKS mechanical environment. And tracking all changes is an integral part of exactly what has been accomplished. Throughout the communication through the connector records all communication, all activity, all changes that were made and all that were accepted, and even those that may not have been accepted is all part of the chronology. So you know exactly which engineer made what changes and when they were made. So the collaboration between the SOLIDWORKS PCB environment and the SOLIDWORKS CAD environment is a completely integrated solution. It's initiated through the collaboration icon on the menu bar. It activates the collaboration panel, which allows for the communication. It's a simple push-pull process to send data or receive data to and from either environment. You're automatically notified when a change is available for viewing and or acceptance. And this is an integral part of the SOLIDWORKS mechanical solution. So no additional software is needed on the mechanical side. This is a capability for SOLIDWORKS PCB and an add-in for those that are using Altium Designer today in a SOLIDWORKS CAD environment. The behavior, the usage is exactly the same regardless. Starting our SOLIDWORKS collaboration demonstration, I have the SOLIDWORKS application running, as well as the SOLIDWORKS PCB application running. Now we can start our board design from either environment. In this case, we're looking at SOLIDWORKS PCB with the schematic with a couple of components that have been placed. This is our board design area, and this is our SOLIDWORKS PCB connector, the lower left-hand side. the way to start this, we can start with a blank design, because there's a lot of information, a lot of thought that has gone into this process up to this point. We've made some technology decisions. Our electrical engineer has made some decisions regarding the types of connectors and other components that are deemed critical for this particular design. So we can simply start by going to the push button and making the request to the mechanical engineer. Please provide the exact board outline. And we will post that. So we're in the printed circuit board design environment. We're communicating with the mechanical engineer that's partnering with us on this design. As the mechanical engineer sitting over here with this simple product from a mechanical engineering perspective, but very complex from a board design creation perspective because of the curves, the complex vertices, the points at which the board needs to reside, and a couple of cutouts. So we'll simply go over here to the SOLIDWORKS PCB add-in. We're going to pull the board and simply select the design that we're working with. And this is our starting point. This is a starting point for the creation of the board and modification of that outline to fit exactly into our enclosure. So from the enclosure, we'll go ahead and go through this process. For all of you that are familiar with SOLIDWORKS mechanical design, you'll be very familiar with the steps that I'm going through right now. So I've simply read the board in. I'm going to determine which surfaces are mated together. So I know that the board needs to mate exactly to this surface here. As the mechanical engineer, the mechanical designer, I've already developed an outline of exactly where my board needs to reside, and as simple as that, I have just created the exact board outline that I need to fit into this. That's it. Now all I need to do is, from my board view, using the connector, I can push this back over to the printed circuit board designer, and I can say, exact board outline created, please place critical components. And we'll post that. As the printed circuit board designer, I immediately see a notification in my lower left hand corner. New changes have been detected. I can view those changes. I can preview what that change is going to be, or I can just go ahead and accept it. And there I have my exact board outline that's been read into my environment, ready for placement of critical components. What you're viewing here is a live situation. Granted, it's a simple design, but everything that you're viewing is happening real time. So at this point, I'm going to go ahead and, using my engineering change order ability, I will look at all the changes, all the differences between the schematic and what's on the board. We'll go ahead and say execute those changes, and all my components are placed in the start location. Now, as a printed circuit board designer, I can go in here and I can simply place these components, quickly placing them in a logical order. This is a typical methodology that, as the engineer, the electrical engineer, has completed some aspect of the schematic design, he or she will then send that data over to the printed circuit board designer so that they can continue with the process. It's a parallel process where the mechanical engineer is working at the same time as the electrical engineer, who's working at the same time as the printed circuit board designer. Once I have my components placed within the confines of the board outline, I can go ahead and say push, and we will post that. And again, going over to the mechanical engineering environment, I'm immediately notified of any changes. Now, imagine that these are two different people with two different licenses sitting in two different spots in your building. All we need as a prerequisite is that they're pointed to the same server. I can go ahead and view these changes. I will be presented with a list of everything that's changed. I can go through and I can select to see what exactly these changes are, so I can go through and preview them all, or I can simply say check all and accept them. And it goes through the process of reading these components in, placing them exactly on the board, exactly on the place that the printed circuit board designer had placed them. And there I have these components placed exactly on the board, and now I'm able to go through my own check. Now, the key here is not just the components being placed on the board, but the components placed on the board with respect to the enclosure. And I can go through the inspection process and verification process. The first problem I see is that this SD card connector does not have the accessibility that I need in order to plug that in. So I'm going to need to make some room. I have the ability at this point to come in here, move these components around, and make some space so that we could actually plug that SD card into this connector. I can continue through, and it looks like the placement of this connector is a little off. What's important for me is to see that, can I plug externally, can I go through this plug-in process? So what I want to do is, I want to move this, and I'll go ahead and move this over. And then I need to look at my connector down here. Now, this is definitely a problem because this connector needs to be accessed through this case, and clearly I can't do it with the way it's placed right now. So I'll go ahead and move this to the exact location so that it protrudes slightly, and I'm done. Through this very simple, very straightforward process, I have avoided at least 2, perhaps 3 ECOs to this design, and perhaps a prototype or 2 that might have been created that would not have worked for us. So at this point, I'll go back over to the board. I can take this and I can push this back over to the printed circuit board designer, and I can post that. In the printed circuit board design environment, again, I see that changes have been detected. I can preview these, and what I get is an animation of the movement of that component to its new proposed location. I can go ahead, check all, accept, and we're done. We have just done 2 complete cycles of communication between the 2 environments in a matter of minutes, and we know that it's correct. In conclusion, SOLIDWORKS PCB offers a complete collaboration solution. We track all changes that are made to the board outline, component placement. We record all activity, who did what, where, and when, with a very easy-to-use interface. And, oh, by the way, we have a complete printed circuit board design solution. For more information, please contact your local SOLIDWORKS sales representative. Thank you.